So, now we look into heating, ventilation and air conditioning, some ideas related to that, some ideas related to HVAC, some ideas related to that. So, HVAC. Now, first thing related to that is a thermal comfort, and some of you would have done a course earlier where we have seen that the main factors which which controls our thermal comfort is the surrounding air temperature. And then the relative humidity. Why so? Because the body cools by evaporation. The heat loss, the moisture loss from the body results in cooling by evaporation, all right. So, relative humidity is important, and then if the surfaces are warm, these surfaces, because the sunlight is falling onto the outer surface, the surface can be warm, warmer than the air. In that case, radiation from these surfaces are also important. And lastly, it is a air velocity which causes forced ventilation, it causes forced cooling of the body, convection, forced convection, and so forced evaporation. So, this is what is important, right? Radiation on the surface, air velocity, we have way of defining them, but typically one would control the temperature and relative humidity only, because in a controlled environment, where in an air conditioned environment, surface temperature and room temperature, wall surface temperature, ceiling surface temperature and air surface temperature, they are nearly same. So, radiations from surfaces can be neglected, and usually it is a closed rooms. So, there will be little natural ventilation, leakages could be there, infiltration it could be there, but that is taken care of. So, air velocity per se is not there to do convective cooling in that sense, significant air velocity is not there, and that also. So, it is by and large steel air, it is closed from all sides, and then we normally do not operate fans etc., if the HVAC is working properly. So, this is also not needed. So, what we try to control is these two, temperature, right, comfortable range of temperature, and generally this is our range. As I said, it will depend upon your social condition, location. In India, it could be to tropical people, we might be happy with 25 degrees centigrade. The cold countries, people might be happier at 20 degrees centigrade. So, that difference is there. Your clothing. So, in summer you do not put on heavy clothes. So, therefore, all these are factors. So, these are fixed accordingly. Relative humidity is important from two point of view. One, it will cause evaporation loss from the body. Now, if it is too low, you feel dry. If it is too low, there will be a lot of moisture loss from your skin and you feel dry. And if it is too humid, too moist, then again there is a problem. The problem is that no evaporation takes place, you will be sweating, you might sweat, start sweating, not a very comfortable situation. So, there is a desirable range of relative humidity, generally around 60. National Building Code you give you the values. So, 25, 60, 50 to 60 degrees centigrade relative humidity would be a good thing, right. So, these two controls. So, we tend to control largely the temperature through supplying air. If we are doing cooling, supply air at certain lower temperature which will enter into the room, absorb the heat from the room, and as it goes out it will exert at room temperature. So, air comes at cool temperature, but it comes at certain moisture level and absorbs the moisture in the room, because you will through your perspiration, sweating may not be there, but perspiration will lose some moisture, and processes involved if there, they will also lose some moisture. So, this moisture it absorbs and then goes out. Therefore, in the process what it does, so we have a fixed range of temperature, as I said 25 plus minus something, 60 maybe 60 degree, 60% relative humidity plus minus something. This is what I want to maintain. So, I supply air which absorbs both moisture as well as heat and goes out. Now, what we do is we control the temperature. Okay, so we have two type of actually heat, take it away, because the air gets heated up, the fresh cool air which I am supplying it gets heated up, so it absorbs sensible heat. Its temperature will increase now. Our supply air temperature is lower, so it absorbs sensible heat, and it also absorbs moisture, vapor. So, certain amount of latent heat. So, both latent heat and sensible heats are removed. So, continuing with thermal comfort, we said that there are factors which affect the thermal comfort, because we are looking at HVAC, heating, ventilation, air conditioning in the systems related to service system related to heating, ventilation and air conditioning. So, you got to know what should be the condition inside the controlled space. So, that depends upon thermal comfort. Now, all the details of thermal comfort we are not covering in this course, but we know the factors which affect your thermal comfort are temperature obviously. So, we got to maintain a specific temperature, then relative humidity, because body can lose heat by evaporation from the skin, and the amount of moisture that the body can lose will depend upon the surrounding relative humidity. So, if the humidity is high, body cannot lose heat and it has an effect on thermal comfort. All right. Similarly, if it is too dry, then also skin gets dried. So, there is a kind of discomfort related to this. So, relative humidity is the other one. Then if the surfaces are hot, then radiation from the surfaces also play a role, but then in conditioned building, surfaces are unlikely to be, ceiling, wall, inside surfaces are unlikely to be warm. They will be similar as the air temperature. And air velocity is, because that can cause forced convection and evaporation from the body. So, it is also important. However, in our case this may not be very important, because this may not be very important because we maintain appropriate temperature and relative humidity within a given range, as we said, operating differential of the design variable. In control system we are talking about. So, we said operating differential of the control variable. So, radiation from the surfaces, that would be negligibly small in our case, and air velocity will be very small, nearly 0, because we will not put on the fan, nearly put on the fan or something of that kind inside an air conditioned room. So, this are not, but these two are very, very important. So, for steel air condition, the desirable values of temperature and relative humidity plus operating differential, that is what we consider. So, that is what we maintain. So, suppose we would be possibly in Indian scenario, you would like to maintain 25 degrees centigrade plus minus 2 or 3, and this might be 65 plus minus or 60 plus percent plus minus some percentages. So, that is usually the code gives you the values, right. This order is similar what I said, but it varies from people to people. Some people might like to keep it at 20 who are from the cold countries. So, they would like to maintain it at 20, right, while in Indian scenario it is 25 is good enough, otherwise you start feeling cold. So, this is one aspect related to thermal comfort. So, this is what we maintain. Now, how do we maintain? We generally, cooling is done by supplying cool air at what is called supply temperature. So, cool air at some supply temperature, it would be supplied into the room, and it will have specific moisture content. It will have some moisture with some moisture, some value of moisture. Now, as this cool air enters the room, it will it will absorb heat and the air can get out from the room. Either you have an exhaust through which the exhaust it can go, or usually it is usually the leakages etc., is there, infiltration is there. So, it can go out on its own, because supply air comes from outside. Obviously, the volume of the room remaining same, the pressure would develop and therefore, air will go out through any kind of leakages and similar sort of things. So, infiltration. So, this is one way. The other way is, of course, you also provide a kind of exhaust which will take out the air. So, it can be exhaust also. So, depending upon the situation, whatever it is. So, what it does, the air that comes in absorbs heat, because it is at lower temperature, attains the room temperature, and same volume of water will go out, volume of air will go out at the room temperature. So, the air that goes out is at room temperature, air that comes in is at supply temperature. Similarly, air that comes in will be having a specific, some given moisture content, but the one that goes out will go out with the moisture content of the room itself. So, it might absorb some moisture from the room and also it will absorb some heat from the room. So, if we are looking at cooling, generally hot heating is done through radiators, so you have actually radiating fins or plates or something through which you would be doing heating. Heating, one problem associated with heating is ensuring uniform heat. Close to the radiator, temperature tends to be higher, and away from it, it tends to be. So, this differential becomes too much actually sometime. So, anyway, that is problem with heating we will look into later on maybe sometime. So, this is what happens, right. So, basically in case of HVAC, there is air velocity is not required, that is what I said, and you supply air at some temperature, lower temperature than the room temperature, it absorbs. So, basically it will be C specific it, specific it rho, volume rho C V mass into specific heat into delta T, that is the amount of heat or what is called sensible heat that will be removed. Sensible heat removed will be this much, but there will be some amount of latent heat removed also, because it might absorb moisture. So, if it absorbs moisture, it would have taken out some moisture vapor, right, moisture vapor. So, if the delta G is a moisture content difference between the supply air and the room air, then the amount of moisture. So, if mass flow rate, mass flow rate, if this is flow rate I am talking of, volume is a flow rate meter cube per second. So, mass flow rate will be corresponding density. So, if we know the mass flow rate and the moisture content difference, then this will be the what we call latent heat removal, latent heat removal. So, QL, QS, and whichever is what we do is we try to control one. We try to control one, we try to control one in the sense that we will see that later on, just few minutes later we will see. Whichever is higher, according to that we decide the supply air temperature, but supply air moisture content will be decided depending upon how much latent heat I want to remove, because now the flow rate temperature, not supply air temperature, the flow rate will be decided based on how much latent heat I want to remove. Delta T of course, based on certain other consideration we will come to that. So, basically what we do, we supply air at some lower temperature and some lower at some lower moisture content. It comes in, absorbs the heat, attains higher temperature, and at the same time it also attains some higher moisture content and then goes out. So, that is what we do. So, basically to bring, that means that outside you will have outside air, which you will be actually outside air, room temperature would be different than outside air temperature. First of all, outside air temperature will be possibly higher, because we are talking of cooling scenario in tropical climate. So, outside air temperature is higher is greater than the room temperature, and this will be further greater than the supply air temperature. This will be still greater than the supply air temperature, right. So, what I have to do? I have to cool this to this temperature, cool the outside air to this temperature. But then what is done is normally total quantity of air that we supply, cool air that we supply, is not all from the fresh air from outside. A portion of the air is recirculated, the supply air is recirculated air. What we do? That means, the air which will go out of the room, you take a part of it and mix it up with the fresh air and then resupply it. Now, otherwise because of economy. So, but how much minimum fresh air we require? That depends upon the hygienic requirement, because you also got to remove carbon dioxide and similar sort of thing from the room. So, for that you need certain amount of fresh air supply, right, because that is called hygienic ventilation requirement. So, minimum fresh air supply is required, because as the inside room would have also taken, like it will also have higher carbon dioxide content or similar sort of odor or similar sort of thing content, because of room temperature will have more compared to fresh air, because of people etc. sitting inside. So, minimum fresh air supply must be maintained, and that is from hygienic point of view, that is called, we call it hygienic ventilation. So, minimum fresh air. So, what you do? You take part outside air and part room air, recirculated room air, mix it. Now, if you see a simple air conditioner, room air conditioner which you might have seen, you would see that it has got fins, it has got a portion through which it actually supplies fresh air, but there is a filter. If you have seen that there is a kind of fins, then you have filter, this filter through which actually it takes the room air, part of the room air it actually sucks in, right, mix up with the fresh air, cool down at lower temperature. So, you do supply fresh air and recirculated air, you actually mix them up and then cool it down to a lower temperature. So, cooling is important. So, if we want to look at the cooling, then we should look at a little bit into the simple principle of refrigeration system, because if you want to cool it, then you have to actually do simple principle of refrigeration, and that is very simple. So, in this one it has got a 4 cycle, typical refrigeration will have a 4 cycle scenario. So, you have what you do, you have an basic principle is you have got refrigerant, right, like I mean one understands this through carbon dioxide, which if you if you increase the pressure after at given temperature, so isotherms let us say. So, at certain pressure, as you go on increasing the pressure in a constant volume, or volume would change, and after certain period of time it will actually become from gas to it will turn into liquid. And then if you circulate this liquid refrigerant, it will absorb water, absorb heat, and again become so you can always take. So, this is the basically principle. So, what is it? You compress it, compress the refrigerant here, right, the compressor. So, the compressed, after compression, this is in liquid form, where then there is a small pressure release valve and it evaporates here, and this is all insulation, it evaporates here. This is a simple principle actually, evaporates here. So, as it evaporates, it got to take the latent heat of evaporation, it takes from the surrounding space and becomes gas again, where it is further compressed, condenses into liquid. So, compressor, condensation, and then there is a it gets condensed into liquid, then this is allowed to expand suddenly and evaporate. So, this is the 4 stages of refrigeration actually. So, it will go on cooling this, because it takes continuously take heat from this space, it will go on cooling this space, and this is all insulation. So, this is how your refrigeration system works. So, that's so we cool the air using this kind of principles, right. Now, you can understand, we will come to this a little bit later on, we can understand this in a psychrometric chart. If you recollect, I am not sure whether I have talked to you related to a psychrometric chart. A psychrometric chart is in this side, I have got what is called dry bulb temperature. Now, this is taken from Chartered Institution of Building Services Engineer. They have the most elaborate one. You find this in SP 41 and you find in net, it's there in open source, plenty of it. So, this is, you have got a psychrometric chart. In this one, on this axis you have got dry bulb temperature, what we call dry bulb temperature, dry bulb temperature. And on this side you have got absolute humidity, the moisture content or absolute humidity, both will be there. And this line is saturation line, this line is saturation line, then 90% relative humidity, 80%, 70%, etc., etc. So, psychrometric chart is a chart which shows variation of, variation of I mean this axes are dry bulb temperature, what we call dry bulb temperature and absolute humidity, moisture content, right, and it shows various relative humidity curves. Now, you can also plot several things here. One of them is called wet bulb temperature, other is specific enthalpy and so on. So, quickly, although in some other class I have actually talked about wet bulb temperature. The wet bulb temperature is one where actually in an environment, if I have the thermometric bulb of the thermometer is wet, there will be evaporation taking place. So, there will be a depression, wet bulb depression compared to the dry bulb temperature. So, if I keep a thermometer which is whose bulb is liquid thermometer, let us say bulb is dry, it will show indicate some temperature, but if I make it like wet jute or similar sort of thing, if I put it or cotton, wrap it around in the bulb, there will be evaporation taking place. So, you will find there is a depression. So, this is called wet bulb temperature. So, difference between or wet bulb depression as we call it, difference between dry bulb temperature and wet bulb temperature, this difference is an indicator of relative humidity. When you have no difference, that means it is 100% saturated, no evaporation is taking place. So, there are lines for wet bulb temperature in this one. Now, in this one we can express the refrigeration processes, we can express also in this diagram refrigeration processes. For example, if I am heating with the moisture content remaining same, the line will be simply horizontal line will be simply moisture content, let us say is this much, and I am heating from some temperature. So, line will be simply horizontal line, right. So, this is what is called simply I am heating temperature is changing, right, I am simply heating, and if I am keeping the temperature same and increasing the moisture content, right, increasing the moisture content. So, this is this will be simply a vertical, this can be expressed to a vertical line. So, several such each processes can be expressed in psychrometric chart. So, let us see how do we do it. So, this is what it is. Now, say as we said, okay, this there is something just I would like to explain. So, this is a constant moisture content, this is the dry bulb temperature, this side is the moisture content, and 100% saturation line is this. So, you have wet bulb temperature something like this, because at 100% saturation dry bulb temperature and wet bulb temperature will be same, they will be same. So, therefore, one can plot them, and as I cool it, let us say I have some moisture in the air and I go on cooling. So, I am going along this direction from here. Now, if I reach here 100% saturation, after that I can't cool it further. If I cool it, there will be condensation. So, this point is called, this point is a dew point, So, if I cool it further, then there will be condensation occurring, right, because the air has got a fixed capacity to hold moisture at a given temperature. So, that is the saturation moisture content. So, air has got a fixed, it has got a max capacity to hold moisture at a given temperature. So, dew point corresponds to that case where the temperature has gone so low that it goes to the for a given moisture content, it has gone to such a low level that now it will it is reached this saturation point. So, you try to further cool it, you cannot go further along this line, rather you will go along this line. So, there will be condensation occurring, right. So, there is a similarly there is something called specific enthalpy line. I will come to this. So, in psychrometric chart actually you can explain or all processes, right. So, let us see something more. I will come back to this, I will come back to or just let me explain this, then okay. So, you can explain, we will do that. Now, what is specific enthalpy or what is enthalpy? Enthalpy is the heat content, right. So, we talk in terms of heat content per unit mass of air, let us say heat content per unit mass of the air, right. So, that is specific enthalpy. Now, you cannot absolute change in enthalpy you can always measure, change in heat content of air or gas you can actually measure, right. So, we take a datum point and this datum point is taken to be 0 degree centigrade. So, enthalpy change above 0 degree centigrade we consider and we assume that all evaporation takes place at 0 degree centigrade. So, supposing that air is at a temperature it is at a moisture content of G and temperature of T, let us say, then its specific enthalpy will be, because the evaporation has taken place at 0 degree centigrade. So, G into latent heat of evaporation, G into latent heat of evaporation L, that is the amount of it would have absorbed, right, plus specific heat of water, right, specific heat of water into delta T or T, because we are taking delta T here corresponds to T degree centigrade minus 0. So, Cw plus this is the moisture content in unit mass of air, So, basically I have unit mass, specific heat of air multiplied by specific heat of air plus Cp plus T. So, this is for the air part of it, this is for the moisture part of it into G, of course, Cw G into delta T, because for unit mass of air, G is the moisture content. So, Cw G delta T. So, you will this is the specific heat. I am not sure this is the notation I am using later on, but just to explain you right now, appropriate notation we will use later on. So, you see this specific enthalpy is a function of temperature and moisture content only. Therefore, I can express this in this is a function of temperature and moisture content only. So, specific enthalpy lines can be found out corresponding to the given moisture content, specific enthalpy value corresponding to a given moisture content and given temperature I can find out. Therefore, I can draw a line. So, these are the this is the specific enthalpy line and this is wet bulb temperature line, So, that is how it is. Now, a system would look something like this. System would look very simply, system would look something like the simple cases. As I said, just to explain, I have some fresh air coming in, there is a filter. This one is a filter. Some portion of it will be recycled air, some portion of it will be recycled air. They get mixed up. They get mixed up together. Then, I might basically, depending upon the situation, there is a cooling that is occurring here, right. There is a cooling and there further this is the evaporator. This is the evaporator of the refrigeration system that I talked about. So, the evaporator is kept here, rest of the system is somewhere there. So, this would the cooling would actually occur here. So, the air that comes in, recirculated air, fresh air passes through some filter again, and then this is this one is no, this is not an evaporator, this is not an evaporator, this is recycled circulated air, fresh air entering, and this is a filter, this is filter, this is also a filter, right. No evaporator here, no evaporation is occurring, evaporator is number 3. similar, you know, so here the cooling is actually occurring, and then after cooling, it, you know, if it depending upon the situation, I mean I might require, there can be condensation occurring, because if I cool it to a lower level, there might be condensation occurring, or if I have to humidify, I might have to spray water or something. So, I will do, so this part is done somewhere there. So, condensation means water will simply come out. For example, you might have seen in room air conditioner, there will be lot of drainages during monsoon season. So, lot of drainages occur, that becomes condensation takes place, and the temperature, the moment you reach the dew point, if you want to cool it further, if the supply temperature is lower than that, then there will be condensation. So, moisture loss occurring, so absolute moisture content now would reduce, and you want to add moisture, then there will be spray, you have to spray or add some moisture. Then you know, if you want to remove some moisture from the air, you might have to cool it to a level where the moisture content, after condensation, sufficient condensation occur to bring the moisture content to a low level. So, if you want some forced condensation to occur, you lower the temperature, then the supply temperature further, so that moisture will condense out. Then you heat it back again. So, there is a heater, there can be a possibility of a heater on this side, then there is a circulation. So, basically steps of such an air conditioner would, actually a simple air conditioner would involve some filter, recirculated air, fresh air, they get mixed up together, then they are cooled to a lower temperature, sometimes condensation can occur. So, therefore, a condenser, and after condensation, if it goes to a lower temperature then required, you might even have to heat it up a little bit. So, that is what it is, that is what the system looks like, right. So, basically from our point of view, what we would like to know is, first thing what we would like to know is how much is the size, capacity of such an air conditioner, right. So, from our point of view, we would like to know what should be the capacity of an air conditioner, and also possibly we would like to suggest what should be, you know, room temperature is known, but obviously if you I mean room temperature and relative humidity etc. you mentioned, you know, but then you would also it is better to be to have the knowledge related to what is the supply air temperature, quantity of supply air and quantity of supply air required, and its moisture content, and similar sort of information or similar sort of ideas. Although it is a part, you know, it is a part, basically it is in the purview of mechanical engineering or air conditioning engineers, services engineers, but then we would like to also have these ideas ourselves. Now, which one? 6 is the fan. So, this circulates into the room, this is the fan, it is actually the fan, so it circulates into the room, right. Now, two things, this we must know, because this has something to do with the economy. How do we fix this? There, as I said, the variables are, our variables are one, obviously we fixed our design condition, that is temperature and relative humidity, that we have said that okay, this is what is fixed. Now, then we the next thing we want to know is how much, what should be the rate of supply of cool air. Now, that would depend upon how much heat I want to remove, right. That would depend upon how much heat I want to remove. Then that is the rate, but rate is also a function of at what temperature I am supplying the cool air, because if we supply at, if we supply at much lower temperature, then because it will mix up, right. So, my heat removal, latent sensible heat removal is mass into, if the flow rate is m dot, let me call it, mass flow rate is m dot, because it's rate, mass flow rate into specific heat into delta T. Now, out of this room temperature is delta T is nothing but room temperature minus the supply air temperature. Now, therefore, I can keep this high, then this will be low. I can keep this high, this will be low. What is fixed to me is that how much heat I want to remove, Q sensible I want to remove, that is fixed to me. So, I can keep this high, then this will be low. Keeping this high means I will keep my supply temperature, supply air temperature at lower level. Its implication is that you need more insulation. Its implication is that you need more insulation if it is a centrally heated system, right. So, more insulation, cost of insulation will increase, but duct size will reduce. Duct size will reduce because my rate will be less. Rate will be this is higher means this will be less. So, okay, this part has got another aspect also, because this is rate, which means that m dot is nothing but rho into V dot, if I may call it, meter cube per second, which would depend upon which is basically nothing but area multiplied by area of the duct multiplied by, flow is basically area into velocity. So, this is area multiplied by velocity. So, if I want to keep this high, this is function of two things, the size of the duct and velocity. Now, I have constraints on each one of them. If I have higher velocity, noises will be higher. So, velocity cannot be increased beyond a point because of noise. Okay, then other thing is I make area larger, which means my cost will increase. So, it is a balance between this one, delta T is a balance between all these things. One issue is insulation cost, and the other issue is velocity cannot be very high. So, I cannot make delta T too small to have m higher, because velocity too high means there will be noise in the duct, and sizing also is an aspect. So, keeping all this in mind, normally up to about 10-12 degree is a supply air temperature differential, that is what we call it. So, we will look into that.